We are back here in the Weather Center with meteorologist Jacob Dickey for this week's Ask Your Meteorologist. Jacob, what's going on? I mean, we had all this heat and hot air, and now people have questions about what just happened on Tuesday.
Nothing happened. Well, something happened, but nothing happened at the same time, right? It's kind of nice.
That's right. So let's just get right into the question. And it says, we had a strong cold front come through Tuesday, and it didn't bring any storms with it. I thought cold fronts brought storms. Why didn't this one?
Yeah, I get the question a couple different versions and ways of that. You typically think cold front, and you're like, oh no, big drop.
Tornadoes.
Really hot to a little cooler. And sometimes that does have that. But when we look at it here, this is what it looked like here in the afternoon on Tuesday when that front coming through. To the north, we were in the 60s. Galesburg, Peru, we were in those upper 80s and 90s across central Illinois. And as that front came on through, then you knew when it came on by, the wind change, dew points started to drop, and temperatures really started to drop down. So we look at a cold front. What is a cold front defined as? Well, a cold front is the leading edge of cold air coming on through of a cold air mass. This air mass here is considered to be a continental Arctic air mass. It's not necessarily Arctic like the winter time, but it originates way up north of the Arctic Circle, so a cooler air mass for summer standards around here. That came all the way down through, and so you have the cold air behind it, and that usually is pushing that warm air out of the way ahead of it. That certainly is what we had happen. The reason it didn't have storms, though, is we need more than just a front to generate storms here. Typically, when we're forecasting for storms, and especially severe thunderstorms, we're looking at 4 overall ingredients. SLIM, shear, lift, instability, and moisture. Your lift comes from a cold front. You can have lift in other sources there, but we do need some wind shear to help tilt our updrafts. If you don't have wind shear, you can still have storms. They're usually much shorter in duration. Instability. Typically, sunshine brings that, but sometimes you can have a situation where it's sunny, yet the atmosphere is very stable. And then moisture, while we've been sweating here at the surface, that moisture has been more from the corn that's been evaporating things off here. And so when we talk about that corn sweat being a source of moisture, doesn't really get all that high in the atmosphere, so things are pretty dry up aloft. We're just sweltering down here at the surface.
Well, I know a lot of people aren't often thinking about corn sweat, but
well, we'll save that for another day, because that's
we should get into that. But I will say people are very happy for that cold front with no storms.
Yes, it feels much nicer out today and all the way into the weekend.
Especially after all that heat that we had. We have time for a couple more questions, I think. There was a picture that came in. They were wondering, what kind of cloud is this?
Yeah, you were doing some cloud spotting, weren't you?
I was.
What would you call that cloud? What do you think?
Well, I saw a different angle of that same cloud, I think, and it looked like Snoopy.
Okay, this is actually a little bit different than the one you saw. You posted some on your page. I posted some on my page. You see how it kind of looks like? I call that a jellyfish cloud.
Okay.
Can you see that? How it's the cloud on top?
Yep.
And the reason I call that a jellyfish cloud is because it looks like there's tentacles hanging down from the parent cloud. I've got another photo that I'll show. Let's see if I can get that up. So here's this other picture. This is the one that came on in. Your cloud is here. Then down below you've got some, looks like tentacle hanging things. This is a much better version of what that looks like. You can see how that really looks like it. That came in May. What happens is that is actually called virga. And when we look at virga, that is actually rain falling there aloft, but beneath it there's dry air. And that dry air evaporates that rain, so it trails off and disappears, and you get those little tentacle-like things hanging down. So you can call it jellyfish cloud if you want, but virga.
That's fascinating. So it's actually a cloud. You're watching it rain.
You're watching it rain,
but it's not come down to the ground.
Evaporate. Yeah. So you will be underneath that. Look up, and oh, it's not raining. Every once in a while, you get one of those big raindrops that sneaks down and gets you,
like, where'd
in
that
the
come
eye.
from?
But
fascinating. Right. Well, we got one more question.
One more.
Also cloud related. How does a shelf cloud form? We've had several of them during the last week's active pattern.
Yeah, do you remember all those shelf cloud photos? You're getting them left, right, up, down, all over the place. And I'll tell you what a shelf cloud is here real quick. First off, if we're looking at a storm from the side here, a shelf cloud is associated with a squall line. So these storms here are extending all the way to you at home and moving in this direction. We got warm air coming in up front of the storm, and that cold air is coming down. Right here is where that shelf cloud forms on it. You look at it on radar, you see that squall line coming on through. You're going to see a leading edge of that's going to have a shelf cloud there with that coming on through. So the shelf cloud is, it's a shelf across the entire sky. It covers the entire horizon there, and you can see that band across. That differs from a wall cloud. A wall cloud is a block that sits right beneath the base of a storm there. And this is one of the photos that we had. Look at the banding in that, too. You see the striation? You might bring that full real fast. Look how impressive that looks. That was one of the great photos I got from Springfield with the storm coming on through. And what's happening is that warm air is coming up to the shelf cloud, the cold air with the wind coming down. You see that? that usually means you're going to get wind and then follow it with some rain.
It definitely looks like something out of a science fiction movie. They are fun to watch those things roll in. Jacob, thank you so much. Don't forget to submit your weather-related questions for next week's Ask Your Meteorologist. There's the info there on the screen. And thanks again, Jacob, for having us today.